All right. I think it's afternoon, isn't it? Good afternoon, everybody. Day flies by. How's build going? Good? How many people have the tablet? Yeah? How many people have given away their iPad because it's so awesome? So welcome to Introduction to Windows Azure, the cloud operating system. My name is Mark Arsinovich, and I'll stop here, just give you a little bit of background about what I've been doing at Microsoft, because a lot of you probably have known me from my Windows days, and actually my whole career has been based on Windows up until literally the last year. I joined Microsoft in 2006, and I worked on Windows, tail end of Windows Vista, which means I wasn't responsible for anything really that was released in Windows Vista, but I was there for the entire Windows 7 lifecycle and then the beginning of Windows 8 planning, which you're seeing today. But last year I decided to move to the Windows Azure team, and I moved to the Windows Azure team because A, it was a good time to transition kind of in between releases of Windows, but B, because a number of people that I respected were over in the Windows Azure team, some people that had actually left Windows just as I'd arrived at Microsoft to go work on Windows Azure. And at the time, I hadn't really paid attention to what they were doing, but I'd started talking to them beginning last year, and I'd also started to look at the trends of where the industry is going and where computing is going. And one of the people that I really respect, Dave Cutler, name that might be familiar to some of you, he was the original architect for VMS and then Windows NT and a couple of other operating systems as well. He was one of the original founders of the Windows Azure team. And so I talked with him, and he shared with me his views, and everything kind of came together, and I decided this is a great opportunity to come and work on what I consider the Windows 3.0 for the cloud, is the opportunity that's in front of Microsoft right now, and I get to be right there in the guts of it, helping to create the platform. There's tons of questions that we don't know the answers to, which makes a lot of fun. That said, I still work on some other things, sysinternals tools, some of you might be familiar with. A couple of new books, sysinternals Thanks. A couple of new books I've published this year. Sysinternals Administrator's Reference with Aaron Margosis was published about a month ago. How many people have a copy of that, out of curiosity? So a few of you. That's obviously the definitive reference to sysinternals. It's the best book on sysinternals there is. It might be the only one, but it's still good. And so really proud of that book. And then the other book there in March published Zero Day, a novel, which is a cyber thriller. If you're interested in cybersecurity, then I think you'll find that book interesting. I try to stay true to the science of cybersecurity and try to portray what I think is a very realistic scenario for what could be happening in the world, and actually that I'm kind of surprised hasn't happened already. But we're here today to talk about Windows Azure. And this talk, just to be clear, is Introduction to Windows Azure. How many people have played with Windows Azure? Just to raise a hands. How many people consider yourselves kind of pretty knowledgeable about Windows Azure? So you're excused. I don't want you giving answers away. So actually, this session really isn't for the people that are already familiar with it. I'm going to be covering some of the basic concepts, starting with the whole thing about what the cloud is. So if you were like me a year ago, I didn't really get the whole cloud thing. What is the cloud? And I heard these various PaaS, IaaS, SaaS things. And so what I'm going to do is talk about those terms and what they mean, and then talk about where Windows Azure fits into that whole spectrum of cloud platforms. Then I'll dive into Azure specifics, talking about the Windows Azure service model. Along the way, I'm going to start building a simple cloud application to demonstrate some of the concepts. Part of that building the cloud application is storage, so I'm going to be focusing a little bit on some basics of storage. And then we're going to actually run the cloud application that we build inside of the dev fabric and watch how you can develop pretty quickly a cloud application. Then I'm going to conclude by talking about a couple of ways that you can update your services once they're up and running, and then how Windows Azure monitors the health of your application and how you communicate from your application to Windows Azure about the status of your app. So this is, when Dilbert covers cloud computing, you know it's made the mainstream of computing. This is about 6 months old. And I think that replace the cloud and the consultant's babble with whatever you've got, and you've got the consultant handbook there. So what is a cloud? This is my definition. There's other people with different definitions. There's a lot of contention. Don't talk about this. This is really in cloud, whatever. But this is what I view as the cloud. On-demand, scalable, multi-tenant, self-service, compute and storage resources. So let's just take a quick look at those. On-demand and scalable. Those, I think, are two key ones. And on-demand means that you get the resources when you need them. Scalable means that you can get as many resources as you need for your application. Self-service means that you don't have to call somebody up and have them do it, that you can do it yourself. And then multi-tenant means it's a shared pool of resources, which means that you're not paying for all of the unused capacity, that whoever set up this cloud is allowing multiple people to come and use it, and that lets them save costs by over-provisioning things and by buying things at scale and operating things at scale. If you look at the graph on the left, this is what a view of traditional server provisioning, and I'd even say that it's an optimistic view of traditional server provisioning. As a workload on an application has peaks and valleys, if you don't have enough server hardware provisioned in your own data center, on-premises data center, to handle it, you've got to go start the process of getting order requisition for more hardware, bring it into the lab, set it up, configure it, get the operating system on it, deploy the application, get the application configured, set up in the networking, and then eventually, when we talk to customers that are running data centers for their own businesses, it takes them literally 2 to 3 months from somebody needing an expansion of hardware and hardware for a new application to actually getting it up and running. By that time, you've already missed your peaks if you haven't anticipated them accurately. And that red shows that you're underutilized. But then when you buy the hardware, you're like, oh, I don't want to ever have that happen again for the same kind of peak, so you over-provision. And then you've got unused capacity as the demand goes down, say around, right after Christmas. You've got all this hardware sitting around doing nothing. And then another spike you didn't anticipate, and the cycle repeats. With cloud provisioning there on the right, because it's on-demand and scalable and self-service, when the application needs capacity, you can dial up the capacity and scale pretty much instantly when you're talking about this, especially with respect to the scale of bringing in servers into a data center. Literally within minutes, you can expand your scale and adapt to the curve pretty accurately and pay for only the capacity that you need. So that's the nutshell sales pitch for the cloud. But there's nuances around types of cloud. And that's where the different types or categories of cloud computing that have kind of emerged come into play. One of those is infrastructure as a service. This was the first type of cloud computing. Amazon, a few years ago, started this. Was really a novel thing, actually. It started everybody thinking about cloud and shared computing. And really, they were running these massive data centers for Amazon.com, and they said, we built this infrastructure, let's let other people use it too. So they started EC2, and then you see other people come into the cloud business over time. Infrastructure as a service, meaning, and Rackspace is another example. But I'll talk about infrastructure as a service, which is essentially rented on-demand servers in somebody else's data center. Then there's platform as a service. This is stepping a level up. Instead of on-demand rented servers, you actually are renting a whole stack of software where you don't have to worry about the operating system and the runtimes. If you don't want to, you can just bring in your own application, toss up the application, and then the cloud provider manages the rest. And that's where Windows Azure fits in. And then finally, you've got software as a service, which isn't a developer concept. This is more of a end user consumption concept, and software as a service has been around forever. Multi-tenant cloud applications, hotmail.com from the mid-90s is an example of a software as a service. When you talk about the degrees here, going from your own servers in your own data center all the way up to software as a service, you are dialing up efficiency at the same time you're dialing down control, and you're dialing up cost as well. When you are provisioning your own standalone servers, for example, you can buy exactly the hardware you want. You can buy the load balancers that you want with the performance characteristics you want, with the number of ports you want, with the speed that you want. You can put in InfiniBand and whatever kind of networking hardware you want. At the same time, you're going to pay for it. You're going to pay for that specialized hardware, buying it in small amounts, having to manage this typically very heterogeneous network. When you go over into platform as a service, this is where we provide it all for you. Windows Azure's data centers are hardware that you don't really have much control over. We're buying in massive amounts, massive scale. We like to be homogeneous. Homogeneity is actually the key to efficiency and low cost and operations in the cloud. But at the same time, you don't get the ability to say, I want a server with 512 gig of RAM like you can now with Windows Server on your own, in your own data center. And just to give you a visual representation of the workflow, when you're comparing infrastructure as a service with platform as a service, with infrastructure as a service, you pick your VM, and you go launch it on, in the cloud provider. You pick the operating system. It has a database software in it, for example. Your next step is to configure it and then get a front end, for example, for other images that have a web server in it. Provision the database, add the tables, add the data, install the application in the VM, and then configure the load balancers, and off you go. So multiple steps. When you talk about, well, and then you manage in VMs, and it's an ongoing maintenance, actually, for all of those infrastructure pieces. When you talk about platform as a service, these grayed boxes are the ones that are provided by the platform provider. In the case of what we're talking about today, it's Windows Azure. So you just provision the database. This would be SQL Azure, for example. And then you deploy the application. And everything else is managed automatically. You didn't have to configure the load balancer. The SQL Azure is maintained by us. The operating system is maintained by us, too. So the only things you had to worry about are your actual data and your app. And that, I think, means that you're not worrying about things that you don't really care about. You don't have to become an expert in maintaining the operating system or configuring SQL Server. That stuff is just all handled automatically. So Windows Azure, of course, our cloud platform, I consider an operating system. It's an operating system that works on not an individual server scale like Windows Server, for example, does, but at a data center level. And it creates this platform that creates the foundation for platform as a service that you then come and bring your applications to. And that foundation includes a bunch of building blocks, starting at the very bottom, pieces like the Fabric controller and the Red Dog front end, which is the interface to all of Windows Azure core services. Windows Azure networking, which is the networking interfaces to our data center networking. And then the middle tier, middleware services, like SQL Azure I mentioned, Windows Azure Storage for storing stuff, and Windows Azure CDN, all things that are built on that foundation beneath it. And then higher up middleware services, some of them that you might have heard of in the keynotes, App Fabric caching, App Fabric access control server, and then the service bus, which is a messaging system. It provides some features that the basic messaging system I'm going to be talking about this afternoon don't provide. That's really the bulk of the Azure stack, and this architecture diagram looks a lot like what you would show for the basic building blocks of a server operating system. The kernel at the bottom, storage, then the middleware services, the DLLs, and other things that make it possible for you to write to your app. So now that we've got the foundational pieces of what a cloud is and where Azure is, platform as a service, you bring your app, let's talk about how you design your app to bring it to Windows Azure. And that involves something called the Windows Azure service model. Another word for it is the Windows Azure application model. And everything about Windows Azure is designed around these principles right here. This is the philosophy of what we've got for cloud applications, is that a cloud application scales out for capacity. This is in contrast to server application, which might scale up for capacity. SQL Server, for example, you want bigger database, you add more RAM, you add more disk to the server. Whereas in the cloud model, the building blocks you've got for your application are all pretty standard sizes. And if you want more capacity, you stamp out more of those common blocks, the VMs. We also scale out for redundancy, as opposed to the server model again, where for redundancy, typically what you do is cluster. And you have got high availability cluster a lot of times with specialized hardware for the clustering solution, for shared disks. Here, you've got a model where everything, you can just stamp out clones for redundancy. And the vision is that any one of those clones is by itself completely meaningless, worthless. It can die, and who cares, because you've got more of them laying around. And asynchronous communication. When you're in the cloud, you're talking to other cloud services. You're talking certainly to clients that are on-premise or floating around in mobile devices. You're also talking to other cloud services that you depend on, like storage or other pieces of your application. And you're talking across the network then, network that you don't have control over. So you've got to have your application designed in a way that it's not tightly coupled with pieces together. Then you get the equivalent of the donut, except in the cloud, if you're tightly coupled. What you want is asynchronous, fire it off, let the other guy pick it up, and then come back to you at some point in time. In the meanwhile, you're servicing other requests, so you're not stuck up on that thing. Short timeouts with retries. If the network fails, if there's a glitch in the network, if there's a glitch in your app, you want to retry it, the same operations that might fail if you get back an error. And that also means that ideally you want to be designed for idempotent operations where it's very hard to get the logic right for repeating or detecting an error, not knowing what exactly went wrong, and then repeating the operation and making sure that that operation didn't happen twice. Because if that happens twice, if you haven't been idempotent designed, then you could be corrupting data. It's very hard to do that right in a distributed world. So the easiest way to design your app is so that if I do this operation again, no big deal. Just applies the operation again. Write this piece of data to this blob. Just fine if that happens twice. And then stateless with durable external storage. The way that you get these clones that don't matter, the only way you get this model of clones where they don't matter is that you don't store any data on the clones that you are worried about. That the data on these clones, because any clone can be shot down, can die, can be on hardware that's unreliable. If it dies, any data that's with it could die. If you're worried about the availability of that data, the durability of that data, then you've got a stateful service and you've got to do replication and all sorts of very complex distributed algorithms when you can let somebody else worry about that by externalizing the data you care about. So this is where you stick your data in something like SQL Azure or SQL storage. And they're the ones that have these massively complex replication algorithms where your data is all replicated, and so you don't have to worry about it. So don't store any stuff on your own machines. And if you look then, we've got two models, the server model on the left and the Azure model on the right. And when you go to that, design your app and design the world for those points that I brought up in the previous slide, you get all these nice benefits that come with it. Like automated consistent application updates. If we've got a clone and we want to update it, we just can basically just delete that clone and create a new one, just with new configuration. That's kind of the conceptual model. It's a little bit more nuanced than that. Automated configuration changes, the same thing. Multi-instance management. All the clones, I could have 1,000 because I've scaled out, or 10,000. I can manage them all with single operations. I can say, give me another clone, delete 5 clones, stop all those clones, update all those clones. I don't have to go to each one individually like I do in a traditional server world. Every box, I got to go and deal with configuring, updating it, making sure that it's there. Here, I tested on one of my clones. If that works, because everything else is a clone of that, it's likely to work too. And I can just issue those things in one operation. You also get scale out. With the stateful model, which is the server model, and the server application stores things in the registry, stores things in the local file system. Can you scale that out easily? Not really. Those applications usually aren't designed to, unless you start from the start to make them designed that way, and that's really hard. So scaling out that kind of application is extremely difficult, but scaling out the clone with the stateless model, very easy. And finally, automated consistent OS servicing. Because we're the platform, we just basically, you bring us your app, we can take your app, effectively lift it off the platform, service the OS, stick your app back down, and nothing changed with your app. It's got the same config, it's got the same bits. When you talk about the traditional server application world, its bits are all mixed in with the operating system. And so it makes it impossible for a traditional Windows app for you to be able to look at a system and say, where's the app? You just don't know. It's sprinkled all over the place. If I update the OS, how's it going to affect the app? Again, you don't really know because it's tangled up with the OS. But here, you give us the app, it's cleanly separated from the underlying infrastructure. Makes that more consistent. So here's Windows Azure, and there's Windows Server. So let's start making a cloud application. Now, here's the requirements for our cloud application. And this is like a marketing app. The marketing guys always get mad when we say Azure without the word Windows or SQL in front of it. So I'm going to say that a few times right now, just to poke them. Azure, 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 Azure. Because Azure is just a color in their minds. Windows Azure is something that Microsoft makes. SQL Azure is something Microsoft makes. So they're really concerned if you're going to go do a presentation and you've got Azure without Windows or SQL in front of it, because then it's like on record, on paper. Okay, you just said it in front of them, but you've actually put it in a PowerPoint that's propagating just nonsense, not staying with branding messaging. So we're going to help them out and make a cloud app called the Branding Police. It's aimed at Microsoft employees, anybody else that wants to talk about Azure, where you can upload a PowerPoint and the service will scan it and look for places where you forgot to put Windows or SQL app in front of Azure and then tell you about those mistakes. And the requirements for our app are traditional cloud, kind of any cloud app. We've got some specific coding ones. We want high availability, of course. We want it so that this thing is up all the time, because you never know when somebody's going to want to scan their PowerPoint file for branding violation. It could be in the middle of the morning. They just finished it, 2 in the morning. So we can't be shutting down the service. It's Saturday, because that might be the time where people are working on it. We want to program in MVC. Now, this is going to be MVC 2 because I'm still having trouble keeping up with all the MVC versions. There's another one from this morning. So, but I'm stuck back on MVC 2, so we're going to work on MVC 2. And then we also want it to be scalable, because we know that this thing is really going to catch on. Just a pain to scan your documents manually for branding violations. Lots of people are going to be uploading their PowerPoints, especially right before events like this or other Azure events. So we wanted the thing to just be able to scale out really easily. So those are our requirements. But how do we model an application like that in Windows Azure? Well, this kind of, if you look at it, lots of cloud applications, most of them, or many of them, are canonical multi-tier applications, just like your service-oriented architecture applications. Here we've got a front end. It's behind a load balancer because we've got multiple front ends to handle load for scaling. And then we've got middle tiers, multiple of those, too, to handle load. So traditional SOA architectures, that middle tier can be hard to scale out. In Windows Azure, it's very easy to scale out. And then we've got durable external storage. So the reason that middle tier is sometimes hard to scale out in SOA is that you've actually put the storage right on the middle tier, and now you've got stateful SQL servers, for example. Here we've got stateless middle tier, everything's external. In the Windows Azure service model, let's talk about how we map our Branding Police application onto that model. You can think of those tiers or components of your application. They're called roles, and your application is called a service. And a service has the definition of the service, the definition of the roles. It has a configuration of the service and the roles. A role, I think of as kind of like a process or a DLL in a Windows process. If we're following that analogy of server apps versus cloud apps, a cloud app is like a process in Windows. In Windows, you build your app by putting together different DLLs. Might be DLL from somebody else, DLL from you, DLLs that you're sharing with other applications, and then you tie them all together in the same process. The same thing is here, where you've got multiple roles. Now, we're using them to represent tiers, but you could have them represent anything, just pieces of your application that are doing separate work, providing internal services for your app. And then we've got multiple instances are required of each of these. And I mentioned this here, and I'm going to mention it later, because this is an important aspect of today's Windows Azure service level agreement, the agreement that we've got with you and that you've got with us. You've got to do something to earn the SLA from us, and that is to have at least 2 instances of each of your roles, so that if one instance fails, the other one stays up. And we guarantee you, or your money back, basically, 99.95% of the time, you will be able to get to one of your 2 roles instances. If you only have one of them, then you're not meeting that SLA. I also want to clear up a little misconception right here, because a lot of people think that Windows Azure's got a separate, different kind of SLA than Amazon. Amazon's, their main thrust is infrastructure as a service with some platform as a service bits and pieces around it. But infrastructure as a service, you think, Amazon's SLA, 99.95. All I need is 1 VM. Here with Azure, I need 2. It turns out with Amazon, their SLA is 99.95. You need 2 VMs to get that SLA. And they have to be in separate availability domains. So in other words, separate data centers or separate parts of data centers. They're kind of opaque about what their availability zones are. But here, all you need is poof up 2 instances, and you're getting our SLA. The way that we achieve this SLA, by the way, is with something called update domains and fault domains, which I'm going to talk about a little bit later. Within a role, the role has the definition, like I said, the configuration, and obviously the code. And the definition includes the name of the role, so you define this name of this piece, or DLL. It also has the role type, which I'll talk about in the next slide. What type of hosting environment do I want? And the size of the VM. So that's basically the clone chunk size. How big do I want these things to when I stamp them out? And there's several sizes. There's extra small, which is a fractional VM, fractional core. There's small, which is a single core with 750 meg of memory. Medium, large, and extra large, which is 8 cores and 14 gig of RAM. So that's the spectrum of building block sizes that you've got. You also define your network endpoints. We want you to, so we can configure the networking topology for your roles to be able to talk to each other in the outside world, to tell us what you want. I want an external input endpoint. I want to be able to people to talk to me through the internet, so you specify that. Or I've got multiple roles that need to talk to each other. And so you tell us what ports you want opened up so that they can talk to each other and how you want those connected. This role wants to be able to talk to that role, so you tell us that. And then as for configuration, there's some configuration that's platform configuration, like the number of instances we consider configuration. How many of these do you want? And the number of update and fault domains, which again, a concept I'll talk about shortly. And then there's configuration that's your configuration. You can define whatever you want as configuration. We propagate it into your VMs, the configuration you specify, so that your role can just simply say, what's the latest foo, and read it from the configuration. So you don't have to worry about, how do I get this new config into my VMs for my roles? You carry it along with the role package. Now for role types, so again, thinking about branding police, what kind of roles do we want in our branding police? We probably want 2 tiers. I think we figured that out. We want a web front end, so that can scale out independently of the workers that are doing the scanning of PowerPoints. But what kind of roles do we want, hosting environment do we want for those 2 tiers? There's currently 3 role types defined in Windows Azure. One is the web role. The web role means that we'll set up IIS 7 for you automatically. You specify some website information, we'll go and configure it all for you. It's designed, obviously, for an ASP or MVC web front end. So it's a convenience for you. The other role type is the worker role. This is just basically a vanilla Windows server role. So you can stick whatever you want in there. You could put Apache in there if you wanted to and create your own web front ends. The benefit you get of it being a hosting environment that we provide is that we'll service it and update it for you and configure it for you. So if you bring Apache in, for example, you're responsible for servicing Apache, configuring Apache. But for IIS, we'll do it for you. But you can stick whatever you want to. Whatever server Windows runs, you can run in your worker role. VM role is the third type. That was introduced about a year ago. Now, the VM role, unfortunately, is given this name that misleads a lot of people. They think VM role means I can just take a VM and just toss it in the cloud. In other words, what Amazon lets you do, essentially, with infrastructure as a service by taking your VMs and pushing them up on EC2. But it's really not that. It's not that capability. And the reason why is connected with what I talked about earlier around the Windows Azure application philosophy, and that is the stateless aspect of it. When you have a VM, you're probably running traditional server workloads inside that VM, like SQL Server. Those applications, of course, store state locally. SQL will create the database right there on one of the disks on that VM. You'll configure it. When you go and configure SQL Server, might be some registry stuff you configure, some SQL Server specific stuff that goes off into configuration files, again stored locally. What happens to all that if you make changes or if the node fails on Windows Azure? Well, it's gone. The node fails, you've just lost those disks, you've just lost that configuration. We'll create another one for you, but it's basically starting at the starting point of the image that you gave us. So that's the VM role, stateless model. You can't stick SQL Server in there because SQL Server isn't designed for the stateless world. So then, when people come to that realization, they go, what the hell is this thing good for? If it's not giving me the ability to bring a VM into the cloud, why the hell would I want this thing? Has anybody used a VM role, by the way? See a few people. And do you like VM role? Thumbs up, thumbs down? No. That's it. Yes, that's a yes. He said no, he didn't like it. And the reason you don't like it is probably because your apps don't work in it the way you thought they might. Is that, yep. Is that right? Or you just don't like it? Oh, you do like it. Oh, I thought you said you didn't like it. Oh, that's even better. Anybody not like it? Yeah, there's one person that nods. Thank you. So what is it good for then? If you think about why would I even want to do this? This is an ability for me to take a VHD and give it to Azure and say, use this as the basis for my role. There's 3 things that it's good for. So when you spin up a new instance of, for example, worker role in Windows Azure, we are very easily and quickly can bring it up because we spin up the OS, stick your role on there, and get it fired up. But if your role code, needs to have a pre-installation phase, where, for example, I need to install a whole bunch of, like Windows Media Encoder that takes, 10 minutes to install. That means whenever I create a new instance, my role is going to sit there for 10 minutes installing stuff. And that's going to make it so that it's very painful to scale out and scale down my application. And Azure also has certain contracts with your app that you've got to now deal with, timing issues on, I got to tell Azure that I'm ready when I'm really not ready because otherwise it'll time out on me. And so what the VM role lets you do is take a VM on premises in Hyper-V and install that component into it, and then take that VHD with it installed already and hand that to us. And so when we spin up a new instance, it's already there, and you don't have to wait that 10 minutes. The manual install config, which obviously you're not going to be in the cloud being able to manually install as you scale out, typing in configuration parameters into dialog boxes. So that's where another place, if you've got a component that requires that, where VM role is good. And then finally, if it's fragile installation, so if it fails every now and then because it's old kind of crappy code, and you don't want that failing in the cloud, so you do it on premise, make sure it worked right, and then you give us that image with it already installed. So that's what, little digression into what VM role is good for. All right, so with that, I think that what we're going to do for branding police, what kind of roles do you think we want for the front end and the middle tier? It's kind of obvious, right? We want the web role, especially because we're MVC2, and we want the worker role for the middle tier to do processing. So let's go build a cloud app and add those 2 roles to it. So I've got Visual Studio here. And I'm going to say new project. And it's a cloud project. I'm going to put it in the demo directory. And we can call this branding police, although we could just leave that alone. And now here we add the roles to the project. And I said I wanted an MVC2 role. Now this is just saying the roles. It's not saying the number of instances of the role. We'll do that later. We also want the the worker role for background work. And now the Visual Studio, and I'm so good that I don't need testing. Let other people worry about that. That's what testers are for, aren't they? So now I've got my app. I've got my 2 roles here, my worker role and my web role, and then the specific projects for those with their own files. So now the next step is, though, we got to figure out, well, actually, let me show you inside the service model, by the way. You can see the service model by looking at the role properties. So if I do, for example, CSDef here, I'm looking at the role. This is what we give to Windows Azure when you upload it. Here's a description of my application. And you can see here, there's the worker role here. And here's the web role. And it automatically went and said, because you're a web role, we know that you want HTTP port 80 modeled. So it did that automatically for us. And then there's CSCFG. And the configuration settings are the connection string for diagnostics. It's automatically configured, so we can have Windows Azure Diagnostics automatically spitting out to some storage, external Windows Azure storage tables. And so that's configured there. But other than that, it's basically just stock framework. So now we need to figure out how we want our 2 roles to communicate with each other. So for that, we need to turn to Windows Azure Storage and figure out which Windows Azure Storage concepts we'd like to leverage. And we've got 2 types of communication we want. We have the place where we're going to have this front end, this website here, down here. This is what the user sees. And they're going to upload a PowerPoint right here that's going to go into the web role. And then the web role is going to want to hand it to one of the worker roles. The worker role is going to want to process it, give the results back, and have it propagate back so that the user can see the results. So we've got, how do we get the PowerPoint sent to the worker role, and how do we get the results back to the user? Let's take a look at Windows Azure Storage to figure out what we want. So the Windows Azure Storage, it's cloud storage, and that means that it's durable. So it's replicated actually 3 times. Every time you write some data to Windows Azure Storage, it replicates it across 3 machines. Same thing with SQL Azure. All data is replicated 3 times. If we lose a blade server up in the cloud, your data is still safe. In fact, I can tolerate multiple failures, and your data is still safe. And if you were watch the keynote this morning, we also announced that we do geo-replication of storage. So Windows Azure Storage is geo-replicated now between pairs of data centers. We've got a data center in the North Central. If you deploy your storage account there, it's replicated with the South Central data center. So it's in the same, it's not like replicating to Europe or vice versa. It's pairs that are, from a compliance perspective, okay for people. And that means that if we lose the data center, we haven't lost your data, at least not up until some number of minutes in the past, when according to the latency of the replication. So it's really, really highly durable. It's also scalable, so you don't really have to worry about, you can toss tons of data into Windows Azure Storage, and it'll scale just nicely with that, and it's highly available, of course, as well. There's ways you can access it through REST APIs. We also have .NET wrappers for all of the Azure storage. We've also got libraries that we provide for other languages like Java and PHP, access to Windows Azure Storage too, so that stuff's all available through us or other people, and you're going to see more of that coming in the future. Now, the 3 storage objects that are supported by Windows Azure Storage, there's blobs. Blob stands for binary large object, and so that's just like a chunk of data, random whatever, picture, typically, video, text file, document. Then there's tables. This is lightly structured, so it's, a lot of people are in this NoSQL kick. How many people are in the NoSQL kick? Anybody? All right, like I said, very few people are in the NoSQL kick. Everybody likes structured storage. But so this is the best of both worlds. It's somewhat structured. So whether you're a structured guy or not, here with tables, you can spew data into essentially tables provided by Windows Azure Storage. And then finally, there's queues, which you take messages and send them through the queue. They can be picked up by other receivers. Receivers in the cloud or on-premise. By the way, just because I'm talking about this in the context of a service we're making in the cloud, you can use Windows Azure Storage by itself. You don't have to use the compute that I've been talking about. So you can communicate through queues between 2 clients. You can stick blobs up in the cloud and have a backup facility in Windows Azure Storage. Let's get a little more detail now about blobs, tables, and queues. First concept with storage is that you get a storage account, and a storage account can have lots of blob containers. A blob container is essentially a grouping of a set of blobs, and you can set sharing policy at the container level. So this is kind of where your security policy goes, at the container. And the security policies we support today, you'll see this probably get more rich in the near future, is either public, everybody can read it, or it's private, and you need a key to be able to read it. You can also associate metadata with the container, so other stuff that you want to annotate your container with, up to 8K of container metadata. And there's APIs to list the blobs in the container. If you look at the blob concepts, it's like this. Account can have multiple containers. Containers have multiple blobs. And I'm going to use a little tool here. This is a Cloud Explorer from a company called Clumsy Leaf Software. There's lots of storage explorers out there. In fact, I've written one that's about 80% done, but I just haven't had time to finish it. And there's so many good free ones out there that I'm wondering if I should even bother or do something else. This is just one of them. The reason I'm showing it is because this tool right here is completely 100% free. There's other ones that are more featured and integrate blob, table, queues, service management all into one thing, and a lot of those cost money. So that's the only reason I'm showing this one. And you can see that I've got a storage account, BabbleCam, and it's got a bunch of containers underneath it. And these containers have a bunch of blobs underneath it. So here's some pictures. And if I double click on this thing, it'll show me the picture. And you can see that there's some basic information, a type of blob that we support 2 types, a block blob, which is good for streaming data into the cloud, and then there's a page blob, which is good for random access. You can annotate it with a type, so that's just a convenience thing. Azure doesn't really give a crap what type it is. This is just for apps to read out, know something about it, the date that's modified, the size. And that's essentially what there is to blobs. Okay, so next we've got tables. A storage account can create however many tables it wants. And there's .NET classes, too, that provide link access to tables, which make it convenient if you like using link. A table is a set of rows, and Windows Azure Storage calls the rows entities. And an entity is a set of properties. It's really not like SQL rows because, again, this is lightly structured. You can add properties to your rows individually. You can say, I want to add this property to this row. I want to add this other property to this other row. And these things are incredibly scalable. Billions of rows with terabytes of data. Some of these other previous concepts have limits, like a blob has a limit of 1 terabyte. But tables go much bigger. And there's 2 properties that together are the unique identity of a particular row in the table. One's called the partition key, and the other one's called the row key. And you define them however you want. Now, the partition key is Windows Azure, a hint to Windows Azure to say, this is kind of where you can split this thing across different storage units, and they don't have to be close together. So I partition, just like SQL partitioning, essentially. Now, for all my rows, though, so the most efficient way to do a filter index is off the partition key. And then the row keys, specific essentially to a particular partition. So those are the only 2 ways to index or filter onto rows, a partition or row key. People always say, I want more indices, even though I don't want SQL. That might be coming as well, something we've heard loud and clear. And here's the equivalent clumsy leaf software. Table Explorer, here's a bunch of tables. And you can see there's row keys here, this is actually from an app, a Windows Phone app that's sticking data up in the cloud. Partition key A, there's only 1 partition key. And at any point in time, I can just go say, hey, I want create a new partition key with a new row key, whatever I want, and I want to create a new property. And that property doesn't actually have to exist already, because I can just create lightly structured hello, save, and I've just created a new row in this table. You can see down here, which doesn't look like any of the others, and it doesn't have to. And you can see it doesn't have these properties that these other rows do. And that's the magic of lightly structured storage. So that's tables. And then finally we have the table just graphically showing you relationship of counts, tables, and rows or entities. And then finally we've got Windows Azure Queues, which are reliable message delivery, asynchronous, highly available, durable. So once you stick a message in the queue, it's there. It's backed by Windows Azure Storage, replicated 3 times, geo-replicated. Maximum size of these things are 64K, so they're meant to be an efficient way to send light, small messages. FIFO in general, but not guaranteed. Remember, everything in the cloud's asynchronous, so it's really hard to guarantee FIFO behavior. And the cool concept about a queue is it's designed for that failure case, designed for failure. Now, if one of your workers, let's say the web role sent a message to the worker role pulled it off the queue, and then the worker role died for some reason because of a bug in your code or because the node went down, what happens to that message? It never gets processed. It's gone. Basically, some client sent something up, and poof, it's gone. You don't want that. You want so that if that node fails, that work eventually gets done. So queues provide that capability with something called the visibility lifetime. You say, I want a invisibility lifetime of 30 seconds. That's about how the maximum worst case scenario for how long it'll take to process this message. So when the worker pulls the item off the queue, it can go chew on it for 30 seconds. If it hasn't finished and then deleted the item from the queue, the item is still there, it's just not visible, so nobody else will be able to pull it off the queue. If he doesn't delete it, it poof, reappears in the queue. So that means another worker can go pull it from the queue. So if that case of the node failing, where after 30 seconds, poof, the item reappears, somebody else monitoring the queue will see it again and pull it off and work on it. And so that's the magic of getting the high availability with queues. So for For our branding police app, what do we want? And this is just the URLs. You specify blob.core, windows.net, table.core, windows.net, so on. They all map together. Now, for branding police, I think what we want, these PPTs can be huge, right? So multi-megabytes, maybe even more than 64 meg, or 64K, so we can't stick these into messages, queue messages. That means we need to use some other concept. It really doesn't make sense to stick them into tables. So let's use blobs for the documents. When somebody uploads a document, let's put it in a blob. And the communication between the two roles, well, we could use tables and roll our own communication mechanism on top of tables, but queues are there, so let's use queues. And so the architecture that we'll come up with here is this. User takes a PowerPoint, uploads it to the website. That hands it to one of the web roles. Now, this is the load balancer that determines which one it goes to. We don't really care. One of the web roles picks it up and creates a blob, gives it a GUID, because we don't care about the name. This is just something used internally. Sticks the PPT in there, then creates a report.txt with a message in it, working on. Remember, we want a quick and dirty thing here that I can demonstrate in front of you. So this is all, it's just going to write some text in there and then do a redirect of the web page to point right at that blob so the user will see working on. Press F5 to refresh. Then it's going to stick a message in the queue that says the name of that blob with the PowerPoint in it. The worker picks it up, scans it, and then updates that blob with the name report.txt to report the violations. So the user, when they press refresh again, they'll see the violations. And that's the architecture of the app. So let's go finish that app, which we started. And for that, I'm going to go to C:demo, and I've got 3 files, 2 for the web role and 2 for the worker, 2 for the web role and 1 for the worker role. The first one is index for the web role. So let's go to the web role and find views and find home and find index. And all this is, it says you upload your PowerPoint, and it has that little button that says upload, and that's it. And then we go to the home controller, and let's go to the controllers, go to home controller, and this is where the front end magic happens, and it's really pretty straightforward. Here we create a cloud storage account, which was from the parameters, the configuration that we handed it. We create a container called documents. Here, create blob container. Then we stick the blob in it. That's this upload from stream.net convenience API to stick the whatever file it is up in that blob. We get a reference, we get a new blob with that report.txt. We write working on it. We say which the name of the file is, and we say, please refresh. Then we create a queue, if it doesn't exist, called incoming. And we stick a message in there. And the only thing the message is the name of the blob. Cloud queue message blob name. And then we sit there and wait for more stuff. Now, that's the end of the web role. Now the worker role picks up. And we need to go modify worker.cs. So worker.cs is right here. And let's paste that in and take a quick look at it. And this part of this is, well, we listen to the incoming queue right here. We get a reference to it. And we just sit there and say while and poll, get message. And we poll every 1 second. We go and look and see if there's an item in the queue. And if there is, we get the reference to that blob that it's pointing at with the report in it. We say, hey, we're working on it. And we tell it which instance we are so that we can see that. And you'll see the reason why. We upload the text that's returned by this generate report, which is simply scanning that blob, the blob with the PowerPoint in it. It's using an open XML library to go scan PowerPoint XML and find the branding violations, and then write that back to that original blob with the .text, and we're done. And that's it. So we just need to add a couple of references here for that open document stuff. So add reference, and there's 2 references we need to add. That one and the document open XML. And we'll do a couple more things. That's where we need to tell it which storage account to use. And we're going to use this data connection string. This is going to be in the roles configuration. It's a connection string, and we just want to point it at the storage emulator because we want to run this in the what we call the dev fabric. Data connection string emulator, and we're done. Let's set a breakpoint. And this is the kind of nice thing about the emulator environment is that let's set a breakpoint here right after we get a message. So I'm back in the worker. Here it's just gotten a message is not null when it pulled the queue. And over in the home controller, let's set a breakpoint right here where we're going to stick the message in the queue. Right there. And then we say F5. And this is going to be launching the Windows Azure Storage Emulator. And in a second, we're going to see IE pop up, and then we're going to have our Branding Police UX. And we're going to upload a little PowerPoint. And here we go, browse. And I'll give it something with some branding violations in it. We do analyze, and we should be hitting a breakpoint. There we are. The blob name is some GUID, like we said. It's about to add the message to the queue. Let's press F5, and now we're going to hit the breakpoint in the worker in that second tier, and it's got the message. There's the blob, and let's just say F5, and we see, please refresh, being processed by instance 0. We only have one instance of each here, and there's the branding violations. So that's done. We've just made a little cloud app. Now the cool thing about what we've just done is this thing meets the requirements we had. Scalable. We just create more instances of the worker or web roles to adapt to more load. And highly available. If any of these things fail, the front end one of the front ends fails, one of the back ends fails, and somebody submits a request, it's going to get through. Just because of the fact we're using scale out for availability, and we're using the queue, which has that cool property I talked about. So that's as easy as it was. We just made a highly available, scalable cloud app. Now the next thing we got to do is maintain it. We got to update it every now and then with new code. Remember I said about services going down for maintenance? Well, I guess maybe I didn't say it, but that's just not the cloud way of doing things. If you do that, if you take a site down for maintenance, you don't get the cloud. Now I'm not going to point fingers at anybody here, but we don't want to do that. So the Windows Azure is designed with a couple of update mechanisms that make it so that you can be highly available through your update process. There's two types of update. One is called in-place, and the other one's called VIP swap. In-place is updating a live service with new code, and a VIP swap lets you deploy a brand new deployment of your app, and then basically switch the public endpoint connection to point at the new one, flipping it from the old one. It's called VIP swap, and I'll show you that in a second. So in-place updates. This is where you've got the concept of update domains. By default, there's 5 configured for your service. You can set up to 20. That's new. I'm announcing that today. New 20, up to 20 update domains. And the concept of update domain, when you set that in the config, we could have done that in Visual Studio, is that when we go and update your app with an in-place update, we take down at most 1/n, where n is your update domain, % of your app at a time. And we do slices through your app. So in this case, let's say that we've got 3 update domains you can see here. We're going to update the service with in-place update. So we're going to take down that first tier, slice, the front end and the middle tier 1, update it. When that is up and running and says it's healthy, we move to the next one and update that one, and then finally we update the last one. So at most, 1/2 of your service was on 3 update domains, but you only had 2 front ends. So at most, half your service was down during the update. It's available through the whole thing. And of course, you can do scale out and do tricks to get higher availability if you need to during your updates, but you're never completely down. Now for VIP swap, here we've got 2 stages. We've got the concept of stages in deployment, production and a staging deployment that are connected to each other. They're part of the same, what we call hosted service. And here we do a VIP swap. We've deployed A prime over there on the right. We say, OK, it's good. Looks like it's operating fine. Let's VIP swap them. And now that production VIP is pointed over to that new instance of the service. So anybody that's talking to my service now just starts now talking to the new one, because those requests are redirected from the load balancers over to there. And then I can delete my old one at my leisure. And as far as the capability differences between these two, a lot of people have had problems with in-place update because there's a lot of things that you haven't been able to change with your service. with in-place updates. So this is also announcing here a bunch of things that we call update relaxation. You'll be able to change everything about your service when you do in-place update. Number of roles, type of endpoints, number of instances, types of VM, sizes of VM, whatever you want, you can change on an in-place update. With VIP swap, you've always been able to change everything except for one thing, and that's the number of your endpoints and types. And that's because the load balancer needs to be able to do a one-to-one mapping between the two deployments. If you've got two endpoints over here, two VIPs, and one over here, it's like, I don't know how to map 2 to 1, and so that's why that's illegal. Let's talk about high availability as we're cruising down here towards the end. Concept of fault domains. This is part of what Windows Azure does to keep your service up and running, even if there's hardware failures in the data center. Every service has fault domains. There's 2 fault domains defined for every service, public service. Some of our internal services have more. If you want to know more about that, come to my next talk. But you get 2. And that means that if there's a single point of failure in the data center, you're going to be spread across those single point of failures if you've got multiple instances. Here we've got that same service that we saw before. It's spread across fault domains. These are independent of each other, update domains and fault domains, by the way. So that's why I'm not showing them together on the same slide. But what you get is your fault domain, which is today a top-of-rack router in the data center. If one of those fails, because you're spread across those racks, your service continues to be available. We will actually try to spread you across more than 2 fault domains, but we guarantee at least 2. And that's how we provide that 99.95, because blades fail in the data center. We have approximately 3% of servers failing every year in our data centers, and as the data centers get older, more fail. And that's just a fact of aging hardware. Anybody that runs their own data centers knows that. Now, the load balancer, it is also watching the health of your service. So it won't start redirecting traffic to one of your front-end instances until your instance says it's ready. So when your service is deployed, your role code starts up. At any point, it can say, it's load balancer, I'm ready. Start sending me traffic. And only until then, load balancer won't. You can also report busy status to the load balancer at any point in time. I've got a live deployment of Brand New Police in the cloud here. And if we remote into one of those instances, and I've got this pre-deployed here, we can use a PowerShell script, just like if we wanted to go in and set my status to busy. Now, what's going to happen is that in a few refreshes of the portal, first the load balancer will time out, or will detect that the thing is busy, and then the portal will show me that the thing is not accessible because it's busy. And that allows me to, for example, my role to do maintenance or say I'm sick, take me out of rotation or whatever. And so we'll see that update shortly. And something to note, that the load balancer keeps an idle connection open for 60 seconds. This bites people sometimes, because if a request comes in from a customer, from a client, into your web role, and it takes longer than 60 seconds for you to process it, and you let that connection just sit there, that the load balancer is going to close it. So the customer comes back and reconnects, they're going to potentially reconnect to a different web role front end. And that means they won't see the results if you are delivering it back from the same one. So something to be aware of is just to use keep alive commands or something to keep that connection open. And the timeouts that are visible to you. This is a timeout chart of timeouts in Azure that are visible to you. So that you're running in a VM. There's an agent of the Fabric controller there called the guest agent that's pinging you or pinging the host. So if the VM fails, the guest agent's going to die. Or if you crash the VM, the agent's going to die. And the Fabric controller will say, oh, something's wrong with that VM, and it will recover the VM. Also, you can see that heartbeat's 5 seconds, and if there's a 10-minute timeout, if the Fabric controller can't talk to your VM for 10 minutes, that's when it says time to blow up your machine. It's going to repave it, basically. You're going to lose all the data because, boom, it's going to say reset the OS. So get a clean one because something's corrupt. And then your role instance, you've got 15 minutes to start. This is where that VM role 10-minute install time thing comes into play. And then you're pinged every 15 seconds. So I'm being pinged every 15 seconds by the guest agent to say, are you busy? And you see role is offline. And if we go in here and take my role offline, and I can do that by running Task Manager. Do you really think I was going to run Task Manager? Really? So I've actually configured all my Windows Azure services to have Process Explorer deployed in them. So what I can do here is take the host. This is what's hosting my role code, and suspend it. And that means that the guest agent, which is right here, is talking to this thing, is going to not be able to talk to it anymore. And there's a timeout there on the chart, which says the role, if the guest agent can't talk to it for 30 seconds, it's going to say, something's wrong with this thing. It's unhealthy. It's going to take us about 40 seconds to see that in the portal because of refreshes and things. But eventually we'll see this thing flip to the role is inaccessible. And that's not a recovery operation. That is an FYI to you. We will not take a recovery operation on that because we're not sure what you want at that point. You might not want us to do anything. But the APIs will return the status, and so you can take corrective measure if you'd like to. And then the load balancer, like I said, it's also pinging. Your web role has a listener there, a probe endpoint. The load balancer is just doing gets on it every 30 seconds. And if it responds, then it says, OK, I can redirect traffic to you. That set busy is what turned off the answer to that get when I did that in PowerShell. Let's see if that thing is shown up. There it is. Role cannot be reached by the load balancer, by the host system. So that's because I suspended that guest agent, or the host, the role host. And one last thing I want to do before I conclude here is, and this might take a couple tries because, let's go and unsuspend that thing. Because I've got actually two versions of this service running up in the cloud, unfortunately, and they're both listening on the same storage account. So what I want to do is try to crash this thing while one of the workers is picked up to work. So let's connect into this other one. And we're going to do the branding police thing by uploading a PowerPoint. Here's the URL of this service. And this is instance 1 over here on the right side. And I've got instance 0 over on the left side here. And I can crash a VM just by killing csrss.exe, the standard old Windows way to do it. This is the first time I've logged in, so it's a new user account being created here, and so this will just take a second. And then the last thing I'll do is upload the PowerPoint. We're going to press refresh. The version of Branding Police in the cloud waits for 15 seconds or 30 seconds. I can't remember what I put in the delay. The worker role will go update that report.txt and say which instance it is, and then it'll just pause for 30 seconds to give me time to kill that instance. Then after another, 30 seconds, the queue message becomes visible again. The other worker role will pick it up, and we'll see things finish automatically. So let's start that out. Whoops, wrong one. Whoop. Windows help. It's asking me if I need help because it looks like I'm kind of floundering. And here we go, CSRSS. So I'm ready to go to kill one or the other. And let's see which one picks it up. Whoops, I didn't mean to notice file. Specify, let's say branding police, Azure talk with my violations, analyze. In a second, it's going to say working on it. Press F5 to see which one picked it up. It's the exact same code that we just built, except it's in the cloud instance 1. This is the guy on the right side. If it's for the one from this service, not the other one that's watching. And I just pressed return. Now this thing is dead because I crashed the VM. Now, if this version of the service picked it up, not the other one that I got running by accident, which I realized literally minutes before the talk, then we're going to see that instance 0, it's the other one picked it up. And so there's another branding police that's also watching the same storage account. It picked it up. But what we would have seen is instance 0 would have picked it up, and it would have come back. So this is instance 1 from the other branding police picked it up. So they're both listening on the same queue. But so the result's the same, just across two different services. And that's the fault tolerance that you get from the queues. So with that, I want to wrap up. 60 minutes is a little short, even for an intro talk. So I wish I had some more time to get a little bit deeper with you. But I hope this gave you an idea of what Windows Azure, really the fundamentally is all about. The cloud, platform as a service, the compute models, the service model, scale out versus scale up, high availability through update domains and fault domains, storage concepts, and then actually seeing it all in practice. So I think that I think the cloud is actually onto something. How many people have not written a cloud app but think you will at this point? And how many people love Windows Azure even though you haven't used it yet? All right, so in actually a half an hour, I'm going way deep under the covers of Windows Azure. This talk in a half an hour inside Windows Azure assumes you're familiar with these concepts. So if you just are now introduced to Windows Azure, the next talk might be a little bit pushing the limit for you a little bit because you hadn't had time to let these things sink in. But I'm going to be showing behind the scenes of Windows Azure like we've never shown before. So I think for those people that are familiar with Azure and want to know what's going on, how we run it, what's underneath, what's the fabric controller, then come to that talk, and that's over in Ballroom B. So I'm going to walk over there. Unfortunately, I don't have time to answer questions because I got to get over there and set up for my demos. So I hope to see you over there, and hope you enjoyed this, and I hope you enjoy the rest of Build. Hope you like your Windows 8. Hope you use Windows Azure, and thank you very much.